Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to create a typical parametric surface, that is, climb bottom. In this video, I will explain how to use the parametric surface data function to create a Wellenkugel surface. Here, the Wellenkugel is a German word. It means wave ball in English. Here, we just want to create a wave ball surface. Here, just show the part of a Wellenkugel surface, so you can see the inside structure of this surface. Here are parametric equation for the Wellenkugel surface. You can see x, y, z coordinates can be expressed by u and v. U, v are parameters. So you can see this expression shows the parametric equation for this surface. Here the u is in the range 0 and 14.5. and v is in the range 0 and 2 pi. Here, we will use the gate tool to clone the source code used in the last video. Here is the download link at GitHub repository. From this link, you can download the source code used in the last video. Now, open a command prompt window and run the following command: git clone, and paste this link. This will generate a WebGPU 28 folder on your local machine. This folder contains the source code used in the last video. Now, we want to change the name of the WebGPU 28 folder to GPU 29. Rename WebGPU 28 to GPU 29 and cd into it. And at this point, we are going to start Visual Studio Code with the command code period. Here is Visual Studio Code interface. Okay, we can close this welcome page. Here contains the source code used in the last video. Now open a new terminal window and run npm install command to restore the npm packages used in this example. Okay, finished. Now all the installed packages are stored in the node modules folder. First, we need to add the Wellenkugel function to the mathfunc.ts file. From src folder, open mathfunc.ts file. Here we need to add a new function. Here is the Wellenkugel function. It takes u, v, and center as its input arguments. Here the center parameter lets you set the location of the Wellenkugel surface. Inside this function, we define x, y, z coordinates as a function of u and v. Use these parametric equations. This function returns the vector 3 position on the surface. Now we can save this file and close it. Next, we need to make some changes to the index.html file. From dist folder, open this file. First, we need to change the 28 to 29 because this is 29th video series. Here we also need to change the H1 title from climb bottom to Wellenkugel surface. The input parameters we use here will be the same as those used in the last video for creating the climb bottom. But we need to change the default scale here from 2 to 1.5 to get a better default size of the surface. Now we can save this file. Next, we need to make some small changes to the main.ts file. From this src folder, open main.ts file. Most code will be identical to that used in creating the client bottle, except here that we need to replace the client bottle function with the Wellenkugel function. And inside the create surface function, we also need to replace the client bottle with the Wellenkugel. And also we need to change the U range from 0 to 40.5. Here the V range is 0 to 2 pi, but we want to see the inside. We only display the part of the surface, so we can see the inside. So here we not 2 pi, we go to 5. So that's also the part of the surface. And we also need to change the deviation for the U and V from 70 to 100, 30 for V to 50. Next, we need to set the X and Z value range as -10 to 10 and then -10 to 10. Here the scale default for 1.5 and also here 1.5 to get the better default size of the surface. Here we also include the scale, scale 1 and color map name as their input arguments. All the other part of the code is the same as that used in the last video. With this framework set up and following the procedure presented here, you can easily create your own 3D parametric surfaces in your WebGPU application by simply define your own parametric functions. Now we finished the modification to the main.ts file, so we can save this file. Up to now, we have finished all the programming. Now we can run the following command on the terminal window to bundle our TypeScript code in production mode. npm run prod. Okay, the bound file is created successfully. Now we can click the Go Live link from this status bar area to open Chrome Canary to view our Wellenkugel surface. Click this link. Here is our Wellenkugel surface with default lighting and color map displayed on this page. Here the scale set the default size of the surface. If you change to 1, for example, you will get a smaller surface here. So we go back 1.5. Here scale 1 let you set the aspect ratio for the surface. For example, we change it to 0.5. You get the sort and fat surface you can see here. So we return back to 0. You can also change the color map for this surface. Here is the default jet color map. You can change to item, for example, brown, cool, copper, grays, hot, HSV, spring, summer, or winter. And this is the default jet. You can also click this camera control, so you can use the mouse to control the motion of the surface, get it inside, outside. Well, this shows that's a part of the surface, so we have this card, so you can see inside. You can see a complete the surface, So we can go back here. So we can, the v is 0 to 5. We can go to 2 pi. So we save this file and rebundle the code. Now let's go back our page. You can see you get a complete the surface. You can see from here how it looks. No cut because it's 0 to 2 pi. So this is a complete Wellenkugel surface. Click animation, you can see the complete surface. You can see that in WebGPU, we can easily create a beautiful 3D surface with lighting and color map effects. Now we have completed this example. In next video, I will show you how to create a snail cell surface with both the lighting and color map effects. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.